Welcome to my company Novogenia. We're now in Austria and I want to give you a little tour to show you what we've built over the last 16 years. So this is our show-off wall. It's quite boring, but you have to have all of the quality certificates. So we are certified for lab testing, for supplement manufacture. We're licensed for medical genetic testing. And essentially those are all of the certificates for this. As I said, it's a lot of work. We're proud of it, but that's the boring part of the job. And here you see a plan of how our building looks at the moment. So this is the ground floor. We are now back here. This is our experience center where we can show people the products that we have, and then we can do a tour. We're actually going to walk through the building today. So the lab is back here, and the whole first floor is cosmetics and supplement manufacture, and we're going to have to dress up for hygiene purposes, and then we're going to see how we are building the products and how we are producing them. So lots of machines, big machines that we've built for this purpose. And here you see the principle of how we create the nutritional supplements. So the whole process starts off with high quality raw materials. So we source them internationally wherever we get the highest quality and the form that we actually need. And once we've done quality tests on the raw materials, we then mix it with water or certain other substances, and then we create something like a cookie dough. So this mass goes into a machine, and you can actually see this back there. It's kind of like a pasta press that has 9 tons of force, and that creates a spaghetti shape. And this is what the spaghettis would look like. They then go into a tumbling machine that breaks these spaghettis into a lot of little pieces. And since they bump against each other, you form all of these little small vesicles or spheres. And this is what the final product looks like. Now, this would just be one specific nutrient, in this case, for example, calcium. And we do this process for every nutrient that we want to produce. So one of them would be coenzyme Q10. So that's actually the color of coenzyme Q10. This one would be fruit, selenium. And so we have different active ingredients that we would then use. And then we've built machines that we're going to see later that allow us to personalize it. So mix it together to create a unique mixture for every individual person. Then these go into a box, and this box is a dispenser. So typically we have 90 days of supplements in one of those boxes, and you just have them in your kitchen, and you take one out every day and take it with yogurt or however you want to take them. These microbeads have a big advantage. So this is a typical amount that you would have in one of those daily sachets. So it's quite a lot. However, if you were to dose those in form of capsules, you would have that amount. And that would be very uncomfortable to take. So we're quite proud that we can actually have a very high density of nutrients in a small volume, but we're always trying to reduce the volume because that's one of the things that people don't like, having to take large volumes. And this actually shows you the difference. This is the same amount of active ingredient in powder form or in microbead form. So we have a very high nutrient density. So why do we put the nutrients in these little microbeads? Well, when we created the first nutritional supplement or the DNA tests for the nutritional supplements, we realized that we really need to create a unique mixture for every person. There's just so many variations. With 60 genes that we're testing, there are more than 700 trillion potential different outcomes. And so it's really required for us to do a separate production process for every individual that we have. So this is where we process the samples. This is the first sample processing room. And we like to work with saliva. We could potentially work with blood and so on as well, but saliva is just most convenient to collect. And the sample kits that we've created ourselves provide a little tube that then has a saliva solution within it. And these are very unique. So we have a barcode on the side and we have a data matrix at the bottom. And this is for one person, and this comes to us from anywhere in the world, and they go into a rack like this. And since they have a data matrix at the bottom, you can scan the whole plate And then everybody gets his own email saying, well, your sample has just arrived. So this is the first sample registration process. And the reason why we're using these tubes and the system is this is a very high throughput system that we use. And in the height of COVID, we managed to do 275,000 tests per single night using this system. We also have the possibility to work with swabs, but then we need these huge robots that then add liquids to it, and it's a quite laborious and slow process, and this is just meant for high throughput analysis. So once we've scanned the plate, it goes into this machine here that uncaps it. So it essentially unscrews all of them, and then we have an open plate that has the perfect format for automatic processing in the laboratory. And then we're done with this process and we can go to the next room. So now we need to extract the DNA from the saliva solution that we got from our customers. And as I said, this is the perfect format for automatic extraction. So this plate goes into a machine like this. And here you can see it has a number of different washing valves. And what this machine does, it adds very tiny little iron beads into the solution. And these have a specific coating so that the DNA will attach to the iron beads. And since they are iron, a magnet can come along and they are attracted to the magnet, and you can lift the DNA out of the saliva solution. And this then goes through a number of different washing baths, and in the end it is released in water again. So essentially the DNA dissolves in water again, we remove the iron beads, and then we have a plate that has 96 different DNA samples of pure DNA in water, and that is ready for the DNA analysis. Now, it turns out that DNA from humans or from viruses is very similar, and so these machines can also do virus extraction. So this is the development of the last 16 years. We started off with this plate. This can do 96 DNA tests in one go. So I take the DNA, I put it into one of those little tubes, we add reagents, and we can test for one gene defect. So it's around 100 tests in one go. A few years later, this became smaller. So that's 400 DNA tests. It's just a smaller tube and smaller volumes that we're working with. Then it became 800 tests in one go, even smaller little tubes. And then we had quite a jump to microfluidics. This is what it is called. So we have 96 different DNA samples and 96 different reagents, and these little lines that you see are channels in the plastic. And so the DNA and the reagents meet in this gray area. Those are 9,000 small chambers where every DNA needs every reagent. And so we do 9,000 DNA tests in a single go. And the next step was more substantial. And here we do 18 million DNA tests in one go. So each one of those, we call this a custom microarray. Each one of those windows is 750,000 small droplets that are glued onto the glass. And I take your DNA and I flush it across one of those little windows, and your DNA will attach to the droplets if you have a certain gene defect. And they then light up, and we can visualize it and say you have a certain gene defect. So we're measuring 750,000 gene defects in every person. Whichever test is being done, we always use the same technology. And then we just pick up the genes we're interested in. Then we use AI to upscale this data. Because if you imagine the DNA strand, you have a gene defect here that we've measured and another one here that we've measured. AI knows, well, if you have those two, you must have these three as well, because they're always inherited together. And so we can actually upscale the data to 72 million different genetic variations. And there's one more step above that, and that is whole genome sequencing. This is only used, it's quite expensive and slow. This is used if you're looking for new things. You do that in hospital cases where there's a rare genetic disease and you actually want the whole genetic code of a human being. So we can also do this, but for the population and the nutrigenetic testing, you would not use that technology. This is the best technology on the market at the moment. So essentially, that's the whole technological development that we've had over the years. Now let me show you which machines process these. So this here, the custom microarray, is processed by an Illumina machine, and you can actually see it working right now. So it takes some of the reagents, it applies them to the little slides that are in the baths at the moment, and then it's incubated, and the whole process takes around 3 to 4 days with incubation overnight. And then in the end, the whole slide is an image. So we have a camera looking at the little individual droplets to show if it has attached, your DNA has attached to a specific gene defect droplet. And this whole process is then processed with a robot. So this keeps it in incubation, and this is the interpretation or the analysis machine. And here you can see a typical result. So every single pixel that lights up here is actually the presence of a gene defect that this specific person has. Whenever it's dark, it means we've tried to test for the gene defect, but it's not present. And so these images are combined, and this contains all of the information of 750,000 different genetic defects that we're testing for. And this is what I call our museum room, because we use this heavily for COVID. What you see here, these machines here, they are PCR machines, and they are actually sufficient to do 600,000 COVID tests per single day. That's more than most countries have ever tested. So you can see it's very miniaturized, and hopefully we'll never have to turn them on again. We do use them for smaller projects, but if another pandemic would come, we are ready for this. So a COVID test is quite simple. You just say, is the DNA of or the RNA of a virus present or not? So it's a lot more simple than the other complex things that we do. But the machines are here and we're ready if they're ever needed again. So this is the laboratory. You can see it's all very miniaturized, highly automated, and we have huge capacities in this laboratory. And once we have the raw data, it then goes into the cloud, and we have AI systems and algorithms that then make interesting products out of this. This is all in the computer cloud, of course. It's hard to show. But once we have the reports, we know what your genetic traits are, which nutrients work for you and which ones don't. And we can then use this information to create your unique nutritional supplement. And to show you how that works, we need to go one floor up. So this is actually one of the areas where we now need to dress up to enter the hygiene area. Now we are in the hygiene area where we produce nutritional supplements and cosmetics. So we're very paranoid about microbiology, about bacteria. And so we have these gates everywhere where you need to sterilize your hands before you can pass to make sure that we keep everything clean and sterile. So we are now in the first step of the cosmetic manufacture. Here we produce concentrates, and that means it's cream, it's stable cream that has one specific ingredient in very high concentrations. And this machine here, for example, produces around 50 liters. This, it creates a vacuum, it adds all of the ingredients, and then it heats it up. And then if you do it right, you create a stable cream that has a certain nutrient in it. So this is our larger amount where we produce 50 liters. This is for 12 liters, it's just a smaller machine. And we produce small batches because cosmetics do expire and we want to dose them very accurately. And so it's better to produce them fresh every day instead of having big tubs that we then would use over 3 years. And we then put the cream into bags like this. So this would be vitamin C cream, for example. And each bag has its own quality control. So it is put under quarantine until we have done all of the microbiology testing, the nutrient testing, and once we know the cream is ready to use, we can then use it in the machines. And the reason why we put them into bags, you will see in the next room. So this is where we would weigh out all of the different ingredients, mix them together, do pH testing and so on. So this is our small development laboratory. So this is our small storage. So we have all of our ingredients in small amounts here. We have a large storage in the basement. So we use all of these for the cosmetics that we make, and whenever anything expires or we need something new, we get it from the basement. And once we've created the creams, we go into the next room, which is the actual personalization machine. So this is the personalization room now. This is where we start creating individual creams for individual people. The manufacturing record is on this machine, and we put the cream in a glass container, and this is our holder for this. And this is actually a balance that can communicate with the machine, so we can actually track and record all of the individual ingredients that we've added to individual tube. This machine here was built by us because there was no machine that could dose very viscous creams in the accuracy that we actually needed. And so what you can see here is individual creams are added to this machine. We have a pressure chamber and then a dosing pump. And so each one of those tubes is a different ingredients that we can add to a cream. And we have to build this machine to fulfill all of the requirements of manufacturing for cosmetics, and because we needed it to be highly accurate for high throughput production. So the machine will then light up and say, we need vitamin C cream, for example. And then the machine lights up and we put a tube here, and then it will start to dose the right amount of this specific cream with vitamin C into it. This communicates with the machine and can exactly give us the information of how much or what dosage we have already dosed, and it continuously calibrates the machine. And now we have the active ingredients in different levels. So it's not mixed, but it's specifically for an individual person. And now we need to mix it within this container. And for this, we use these machines. They turn the tube in 2 axes and mix it within the container itself. And then we have stable cream specifically personalized for that one person. So what is missing now is the individual label. So now we have your cream mix, and now we need to label it. And the label needs to have your name on it and the legal requirements of all of the ingredients in what order they have to be. So we've built this label applicator, and this allows the label to then be printed onto the bottle itself. And the label will then look something like this. So it has your name here, the ingredients list, and is all legal according to legal regulations. And now the product is theoretically finished. However, there's actually a big difficulty in the EU because personalized cosmetics are actually not legal in the EU. Because if you make a cosmetic, you have very big legal requirements. So for one, you need to create a 150-page security document for the specific cream that you're creating. The second one is you need to find a scientist, a toxicologist, that does a report on the dosages that you want to use, and he needs to find it to be safe. So you need a toxicological report for this specific dosage. Then you need to register it on different databases. And so that's a lot of work that needs to be done. And every batch that you produce needs to be microbiologically tested as well. So you need to see if bacteria grow in it. So that's a lot of work, but if you create a standard cosmetic, you just produce 1 million of those. You do that once and then you can produce the product, and you just test the batch once. We are creating unique product. So there will never be a cream exactly like this again. And it's just this one bottle. And we found the only way for this to become legal is that we fulfill all of those legal requirements. So while we create the label, we have an IT system that creates this 150-page document, safety document on this. And then we have a toxicologist that produce software with us where we can put the ingredients in, and that then creates an automatic report if we are within certain ranges. The next thing is we need to microbiology test every batch. Now, one batch is one bottle in our case. So actually the first 4 pumps go into our microbiology lab, and we see if any bacteria are growing. They never do, but we need the records that we've actually tested it. And so we're fulfilling all of the legal requirements for the cosmetics, even though we just produce one piece. And if we have a day serum, night serum, body lotion, we do the whole process 3 times. So this allowed us to produce personalized cosmetics completely legally on an industrial scale. There are some ways that competitors have tried in the past. One easy way is to just create 6 standard cosmetics and just stick your name on the best fit. So that's pseudo-personalization. And another one, that's actually my favorite, he sends you lots of little bottles and he says, okay, mix them together yourself, because then you broke the law and I just sold raw materials. And so that's the kind of workaround. So we are the only ones that can produce personalized cosmetics at this scale, at this quality, completely legally. So this was a cosmetics manufacturer, and we're now in the nutritional supplement manufacture, which is a completely different section in our facility. So what we see here is actually our storage of the microbeads that we've created. Each one of these tubs has a certain microbead in it. And you can see they have a quality control sticker, so we only use it once the quality control is done. We have a sticker if it's actually in active use. And if we look inside one of those, we are testing more than any other laboratory, because if you create a nutritional supplement for vitamin C, for example, the label would say you have 100 milligrams of vitamin C. And legally, you're allowed to produce this with 80 milligrams, so 20% less, or 40% more, 140 milligrams. So there's quite a big range that's legal if the label says a certain amount. But if we use that kind of accuracy, there's no point in personalizing. And so we actually want to be 2% accurate and not 40% up or down. And so we test more than any other company. We first test all of the raw materials individually. So we know that vitamin C is very, very pure, but not 100%. And then we create the microbeads, and then we retest those, because we added 30% vitamin C doesn't mean it ended up in there. Maybe we have 28% of vitamin C in the end. And then we can use this actualized dosage, and we just add a little more to get the exact dose. And so if you look at one box of nutritional supplements, you can trace back more than 100 quality control tests to this single individual box. So no other company tests to that level, and that allows us to be so extremely accurate in our dosing. And so while others go 40% off label, we saw that we have only 2% variation from one daily sachet to the next. So if you take it daily, you're sure to get the right daily dose every day. So this is where we produce the microbeads. That's one of the production steps that we have. We need some extra protective gear, and then we can go inside and see how it's done. Here we add the different powders. We add water, and this creates a kind of cookie dough. It's kind of moist, and this then goes into a cartridge that you can see here. So it's around 1 kilo of this dough, and this then goes into the spaghetti machine. So small batches go on trays, and they go into a dehydrator to dry them. And big batches up to 100 kilos go into big trolleys that go into our big drying machine. These large batches of certain microbeads that we need large volumes of, we use this trolley here. So it has a sieve at the bottom, and we can fill it up with almost 100 kilos of wet microbeads. And this can then be moved over to the drying machine that I'm going to show you now. So the trolley goes in here, and this machine takes hot air and flows it through. And so they start flying through the air, and they are drying very quickly. And once they are dry, we can add beeswax that is molten, and that creates a small layer around the microbead, and that masks the taste. And so you don't have the bitter taste of many of these vitamins. And so essentially this is where we finish the final production of one batch of microbeads. They then go into the tubs, into quarantine, and once they've passed the testing, we can then start using them. And this is where we get into the complex machinery territory. This is our first prototype that is a personalization machine. So we bought lots of components, and we built this machine ourselves. What you see here is 32 chambers that have each different type of microbeads. One is vitamin C, one is calcium, and so on. And this machine then takes the production records and knows for the mix of Daniel, we need 28 grams of vitamin C microbeads and 280 of calcium. And then these computers program the machine, and they weigh out this exact dosage, and then they inject all of the microbeads, and then we have one mix that is around 1.5 kilos of microbeads specifically mixed for this one specific person. So here you can see what a final mix might look like. So you can see all of the different colored microbeads. This is specifically for one person and is ready to be packaged into the daily sachets. And that is the next machine. So when we first created the supplements, we initially had tubs with a spoon, and you would just take your daily dose. And that was very easy to package. We didn't need any machines. However, we realized that people always optimistically measured their amounts, and so they took too much every day, and at the end of the 3-month period they ran out and they were unhappy. And so we realized we really need to package it into daily sachets for them to get the right dose. And so first we bought the cheapest machine components, and we built our own prototype to actually put the nutrients into a sachet and print the name on it. And once we saw that the market responded well, we built the next machine, and then this is the third generation that produces these. So what you would do is you add the individual mix for different people in here. The machine knows which customer it is, and then the machine doses every daily dose into a little sachet, and that goes up here, and then it's being printed. The name is being printed exactly on the sachet that we are producing, and that then goes through the methyl detector, and it's being weighed for quality control. If the weight is off, it's being ejected, and only the ones that pass all of those tests are finally produced. Now, let me show you the newest machine that we have. And again, legal requirements are not prepared for personalized supplements. And this is why we produce the supplements that we actually put in a box, but we have to produce some extra ones. And that is because usually when you produce a supplement, you produce 1,000 individual and identical products, and you need to keep one in case there's an issue so that you can do some testing. And we need to overproduce so we can keep those back, and if there's ever an issue, we have some where we can do some quality tests. And so we overproduce to fulfill the legal requirements. These are the final supplements. So they are produced for one specific person, and on the back you see the ingredients, and this goes to America, so this is all FDA compliant, and we have all of the quality control records. This then goes on a pallet and goes to the US by plane. So now the DNA test is done, and we need to create the specific booklet. And this was one of the last things that we still outsourced, but we became so fast in doing a DNA test that printing externally took longer. And so we print the whole booklet in here. So it's being created here. The booklet goes in, it's being cut, it's being glued, and then this machine outputs the specific report. And this is made for one specific person. This is a beauty report as an example, and you can read everything about your beauty as the instruction manual for your skin in this case. And now all of these products need to meet here. So we have the supplements, we have the reports, and we have the cosmetics, and they need to meet here, go in the same box, and go out the door. And depending on where we need to ship it, we ship worldwide from the US to Japan. This needs to be shipped very quickly. And we've become very, very fast. So it took 4 weeks at the beginning, but now we're down to around 4 to 5 days for the DNA test, 1 day for printing. The supplements can be done in that time, the cosmetics can be done in that time. And so within 4 to 5 days, we can produce the whole product and ship it out to the customer for them to enjoy the products. So this is the facility that we have. It took us 16 years to get here. We have built a lot of technologies and we've improved them over the years. And you can see that everything works, but we've run out of space. And so what we're doing at the moment is build a new facility that's 3 times larger and much more automated, so that we can have more space for the packaging machines and so on. And the new facility will be done in 2027, and it will allow us to produce 700 million euros worth of products per year. And I hope you enjoyed this. It certainly was fun building all of this, and you get an idea of what kind of technologies and what effort goes into producing personalized supplements.